Okay. Section 1.2, linear equations and rational equations. This too should be somewhat review, but not as much review as section 1.1. 1.1 shouldn't have confused anybody. Here on the harder problems, you're saying, oh, that's kind of hard. That's okay. But it shouldn't sound like I'm speaking a complete foreign language. It should sound like something you've heard before, but maybe forgot a little bit here and there. So, starting with linear equations. A linear equation has the form ax plus b equals c. Mathematically, what this means is a linear equation is an equation in which there are no exponents on the variables other than 1. There are no variables in denominators or radicals. So the basic idea here is that there are no exponents on the variables. There are no variables in radicals or denominators. And when we have those things, that is a linear equation. Now up here, this ax plus b equals c, that's a linear equation, but it's like the most simple linear equation that you could possibly see. What you will be looking for in general to identify these equations is that you have no exponents on the variables other than 1, and no variables in radicals or denominators. That will identify it as a linear equation, and then will tell you to use these steps. Now here are the steps that I will use every single time. These are not necessarily written in stone, especially steps 1 and 2. But my basic steps that I will always follow are step 1, clear parentheses. 2, clear fractions by multiplying all terms on both sides by the common denominator. Factor denominators first. There's the thing, factor denominators first. Factoring is a skill that we hope you bring with you to the class. That this is not supposed to be the first math class you've ever taken. You were supposed to take math all the way through high school, and we're kind of hoping that when you come, you remember a whole lot of that math. And so factoring is a prerequisite skill. If you need help with factoring, you can try, depending on what the COVID situation turns out to be, you can come to my office. In Folio, I will have some videos posted about factoring, but that's a skill that somehow we'll have to try to recapture for you. So, step 2, clear fractions by multiplying all terms of both sides by the common denominator. 3, simplify the left and right sides of the equation, combining all like terms. 4, get the variable on one side. It doesn't matter which side, but we usually get the variable on the left side. 5, add or subtract as necessary. 6, divide both sides of the equation by the coefficient of the variable. And 7, check. That checking step is optional, but if you've got a few moments at the end of a test, check the things that you can check. And we will go over how we can check these things. So 1, find the value of the variable that satisfies the equation. Check your solution. So just going through my steps, the first thing I'm going to do is clear the parentheses. So I'm going to distribute that 3. And so I'm going to get 5x plus 18 plus 6x equals 4. And then really importantly, that minus sign also distributes. And so that's going to be minus x plus 7. There are no fractions, so I'll skip step 2. 3, simplify the left and the right sides of the equation, combining all like terms. So over here, I'm going to add my 5x and 6x for 11x plus 18. And over on the other side, I'm going to combine my 4 and the 7 for negative x plus 11. Order of the terms doesn't matter as long as you have all the terms, same terms with the same sign. 4, get the variable together. So I'm going to add x to both sides. I like my variables on the left, so that's where I'm going to go. Then add or subtract. I want to eventually get that x alone, so I'm going to subtract the 18 from both sides and get 12x equals negative 7. And then divide, and I get x equals negative 7/12. And there's my happy answer. Do not give me a decimal unless I gave you a decimal. I want what's always called the exact solution. And so let's say the answer was 1/3 instead of this. and you wrote 0.333. 0.333 is not the same thing as 1/3. They're very close to each other, but they aren't the same. So never give me a decimal answer unless I give you a decimal answer. So that's the answer I want to see. So we have done that problem, but now we're not quite finished with the whole thing. It said check. Then what you might see in my lab math. Now, quiz or test time, there's what you give me. But you might see this in the computer, and the reason why I keep saying might is this the way it looked in fall 19? Is this the way it's going to look in fall 20? I am not sure. And if these videos go on into the future, so if this video goes much further than fall 20, here's what it looked like in fall 19. Whatever time frame you are in now, I don't know for sure if the computer will look like this in whatever time frame you're looking at. But in fall 19, this is the way the answers looked. Okay, so continued. What is the solution? Select the correct choice below, if necessary, fill in the answer box to complete your choice. So my solution set is -7/12 is what I would choose there. Now, checking this, and I didn't check it, and I didn't leave room for checking it. So let's go back up here and check it. I should have done that over here. Checking. We're going to check graphically. So what I'm going to do is I'm going to take my original equation. I'm going to set it equal to 0. So that's going to be 5x plus 3 times 6 plus 2x minus 4 plus x plus 7 equals 0. Notice I didn't distribute anything. I just moved everything to the left side. So moving the 4 to the left, it became negative. Moving this minus 7, minus x, the quantity x plus 7, it became positive. And then I'm going to graph in y1 5x plus 3 times 6 plus 2x minus 4x plus 7. And then the x-intercept should be -7/12. And for checking purposes only, -7/12 is roughly -0.58333. So that's how I'm going to check it. And checking, since we have a calculator, that's the easiest way to check. Now, if you want to take -7/12 and plug it into the original equation and see that the original equation is true, you could do that, but with that number, that -7/12, that's a lot of arithmetic. So we are going to check it this way. So there you can see what we got there. So I'm going to press y equals, I'm going to clear it, and then I'm going to put in there what I had, 5x plus 3 parentheses 6 plus 2x in the parentheses minus 4 plus parentheses x plus 7. So I put it in there just the way I saw it, and then most of the time my standard window of zoom 6 from -10 to 10 should do it. And so there's my answer, and I don't think I'm right. And I didn't mean to be wrong. You know, we can do a trace, find that x-intercept. And so trace, x-intercept, just start tracing until we see that little blinking cursor. And that's close enough. Well, maybe I am right. So, no, excuse me. So, I just lost my train of thought. So I'm close to the x-intercept, and look here, it says negative 1.7, which is not my answer. So there are two ways I could be wrong here. I could have possibly typed the equation in wrong, or I've made a mistake over here. So let's see which way I am wrong, and I already see my mistake. Right there. I didn't distribute that minus sign. And so there is the importance of checking. I checked my answer. It wasn't right. And so I indeed made a mistake. That it says that my answer should be close to negative 1.7. It's not. I made a mistake. So let's fix this. This should be minus. And I honestly didn't do that on purpose. And then this, 4 minus 7 will be negative 3. Then this will be negative 3. This will be negative 21. And so I get negative 21/12, which I can simplify that, divide both those by 3, negative 7/4. And so now when we go to check over here, negative 7/4, which is also equal to negative 1.75. So there's what I think the answer should be now. And when I go back and look at my picture, there I'm close to the x-intercept. Let's zoom in a little bit so you can see a little bit better. There I'm close to the x-intercept. I'm not quite there, but a rough check. So I'm close to the x-intercept. My x-coordinate is negative 1.7. We said the answer should be negative 1.75. That is darn close to, that's close to the x-intercept, and it's close to negative 1.75. So I feel good about this problem. It is right. But there's the importance of checking your answers. I made a tiny little error, and I didn't do it on purpose. It was an honest to goodness error. I made a tiny little error, but by checking, I caught that error. But that's the way we're going to check our answers. We're going to set everybody equal to 0. Go back out so we can see everything. Set the equation equal to 0, graph it, and then make sure that the x-intercept matches the answer. And so then, like I said here, MyLab Math might have this sort of thing. And so you're going to fill in the correct answer box. And so we'll put in the correct answer now. And we get negative 7/4. And that's where we'll end this video. We're going to keep the videos to under 15 minutes. I use YouTube to upload the videos and whatnot, and I can't do anything longer than 15 minutes in YouTube. So, end of this video, and then we'll start with example 2 in the next video.